So I finally managed to get around to creating a prototype of my controllable pitch fan or propeller. The idea is to be able to vary the pitch of the fan or propeller blade as the propeller shaft is spinning, and to achieve a pitch appropriate for the speed, the current speed of the shaft. Rather than use complex hydraulics, I've employed this notion from simple nut and bolt arrangement. The pitch of the fan blade would be manipulated by the axial motion of a nut as it spun on the shaft. So as the shaft is spinning, you could induce additional rotations backwards and forwards on the bolt or shaft in order to vary the pitch of the propeller blades. So the primary advantage of this approach is its simplicity, but it's based on the mechanical advantage posed by the nut and bolts thread. It's easy to spin the nut in either direction, but difficult to move the nut with any sort of axial force. So I've applied this to the shaft of my fan or propeller. There are two ways of achieving this rotation on the nut. One with a gear profile, which is based on a gear profile on the exterior surface of the nut, which is in turn driven by a pinion gear. And then a second method where this nut is made of a ferromagnetic material, and magnets not coupled to the shaft cause it to spin in addition to whatever the shaft is rotating. The magnetic approach is under license as an automotive cooling fan at the moment, so I've based my prototype on the second approach by using a gear profile on the exterior of the equivalent of the nut. So this is basically just a cylinder with a thread on the interior and a spur gear profile on the exterior. The axial motion of this, what I've called an axial modulator, pushes this pitch modulator, which is just a sleeve on the shaft, backwards and forwards. And the rack and pinion style mechanism I've used between the fan blade, which has a gear on the bottom, and the rack, which is just linear gear teeth, causes the pitch of the fan blade to change as the pitch modulator moves axially. So in the age of personal aircraft, which will soon be upon us, in the age of drones, you can imagine that this will be an important simplification over hydraulics, not only in terms of the cost of the mechanism, but the ease of maintenance and its simplicity. This could also be applied to turbo machinery, which is a field that has yet to find a suitable mechanism to vary the pitch of the turbo blades. So the idea is that the fan blade or propeller blade would be driven by one motor or some sort of propulsor, and then a secondary shaft would be used to impart additional rotation on the axial modulator. So in this case it would be a two-motor operation. The control, from a controls perspective, it's slightly more interesting than regular run-of-the-mill shaft. The modulation of the axial modulator would have to be achieved by controlling this secondary shaft so that its tangential velocity at its teeth matches the tangential velocity of the axial modulator in order to keep the axial modulator stationary. So you can imagine if you were to spin this shaft and lock this shaft, that would cause the axial modulator to move. So a stationary pinion shaft would not cause a stationary axial modulator. So in order to have the axial modulator stationary, these have to be spun at proportionate speeds, and then control of the axial modulator would be achieved by either speeding this shaft up or slowing it down. This is similar to DVDT control on used in dynamometers. So I have an electrified approach or apparatus. You can see I have two motors, as I said, one to drive the rotation of the shaft and one to vary the pitch of the blades. I have a distance sensor here which measures the distance to the axial modulator. You can imagine that would give a one-to-one indication of the pitch of the fan blades. So in this case, the fan blades are almost at 90 degrees. And when electrified, no longer at 90 degrees and going to almost flat. So you can see the fan blades are now flat, whereas before they were at a 90-degree angle. I have a 3D model. I'm willing to share the model for evaluation purposes or academic purposes. If anyone is interested, please feel free to email me at the email address indicated at the start of this video.